Now we will be going through example 4 from lesson 1.4, permutations with identical items. So question 4a says how many different 7-digit numbers can be made from the digits 8, 5, 3, 3, 3, 0, 0. All of the digits must be used, and the number cannot start with 0. Now the reason the number can't start with 0 is because if we have a 0 in front, it is no longer a 7-digit number. At that point, this is a 6-digit number. For example, if I have something like 0, 1, 2, 3, 4, 5, that's the same thing as 1, 2, 3, 4, 5. So because of that, 0 cannot be in the front. So let's determine how many ways we can rearrange these numbers. So we'll start by mapping out the 7 spaces for our numbers. 1, 2, 3, 4, 5, 6, 7. Now this first spot here can't be 0. So that means it only leaves 1, 2, 3, 4, 5 different numbers possible. So we put a 5 right here. Then for the second spot, one of the numbers has already been selected to fill the first spot. This means we only have 6 numbers left to fill that spot. Now that that spot is filled, we only have 5 numbers left to fill the next one, then 4 numbers, then 3 numbers, then 2, and 1. And for this 7-digit number, we require the first number and the second number and the third number. Therefore, we can use our multiplicative principle and multiply. Now we can just multiply those. So 5 times 6 times 5 times 4 times 3 times 2 times 1 is equal to 3,600. Now we must account for any identical items. So I'm going to divide and I'm going to identify my identical items. So if I look at my numbers, I have these 3s here. So I have 1 3, 2 3, and 3 3s. So I'm going to divide by 3 factorial to account for the fact that there are 3 identical 3s. So that is because we have 3 3s. Now I also have 2 0s. So I also need to account for the fact that I have these 2 0s. So I divide by 2 factorial, and that is for my 2 0s. So now I can divide that, and that equals 300. So now let's up the difficulty level just a little bit more. So question B asks, how many of these numbers are even? So again, the numbers we're working with are 8, 5, 3, 3, 3, 0, and 0. So in order for this number to be even, it can either end in a 0 or an 8. If you think of all of the even numbers, they all end with an even number if they're multiple digits long. So in order for our number to be even, it must end in 0 or 8. Now, if we see this word or, we have 2 different cases. And when we use the word or, what that is our additive principle. So we need to determine how many ways we can make a 7-digit number ending in 0 and how many ways we can make a 7-digit number ending in 8. So let's look at that first case. Case 1 ends in a 0. So I'm going to write out all of my digits. 1, 2, 3, 4, 5, 6, 7. Now there's a few things that we know. First and foremost, this one has to be a 0 because we're saying that it has to end in 0. Now, there's one way we can do that. We're going to assign one of the zeros to be here. Doesn't matter which one, we're just going to assign one of them. Then, for our first number, it can't be 0. That rule is still in effect because then it would not be a 7-digit number. So up here, it can't be a 0. So because we've already assigned 0 to the last spot, and this one can't be 0, we have eliminated these two numbers. We've eliminated the two zeros. That means for this first number, it can only be 8, 5, 3, 3, or 3. So there are only 5 options to go there. Now, for our next options, we've already assigned values to our first and last spaces. So we have 5 numbers left to assign here, 4 numbers, 3 numbers, 2 numbers, and 1 number. Now, because I require a first number and a second, and a third, etc., I'm going to multiply, and that is equal to 600, and now we need to account for our identical terms. This is where things get a little confusing. Because we already have a 0 on the end, and it has to be there, the only area in which I could potentially have any identical terms is in the middle here. And that's because we already know the number on the end is a 0 for sure. Now, because we've already used that 0 on the end, there's only one 0 in this middle bit here. That means, for this particular case, 0 is no longer an identical term. There's only one 0 that could move around, so we don't need to account for that. However, we still do need to account for those 3's. For these 3's up here, those ones are identical terms. So we do have to account for them. So we'll divide by 3 factorial because there were 3 3's. And that will give us 100. Now let's look at case 2. This is where we end with an 8. So we'll map out our options, 2, 3, 4, 5, 6, 7. And our last one here has to be an 8, right? Because we're saying it ends with 8. So there's only one way that can happen. Now again here, we still can't have a 0 in front. In addition to that, we also can't have an 8. This is because the 8 must be at the end. So this one can't be 0 or 8. So that means we've eliminated the 8 and the zeros, so I only have 4 options. Now for the others, I have already assigned 2 out of the 7 numbers, so I have 5 left for here, 4 left, 3 left, 2 left, and 1 left. And then we multiply them all together, and that leaves us with 480, and now we account for our identical terms. Now, just like before, we still have our 3's, and there's 3 of them, so we divide by 3 factorial. But in this case, because in here, we have both zeros that are going to be living in that middle spot, we do need to account for 0 as an identical term. So there are 2 zeros, so we divide by 2 factorial. And when we put that in our calculator, we will get 40. Now, to find our total, we add up everything from case 1 and everything from case 2, and we have 140 as our final answer.